Hey, folks. How's it going? How's today? Are we doing great? I am. Pretty good today. Let's see. Testing things, getting things set up. Today, what do you know? We're hacking on jank. Johnny, just getting started. I appreciate that sub. 3 months in a row. How you doing, Johnny? How's your day going? It's okay. A lot of studying. What are you studying? What are you studying for now? What class? Final exams for your bachelor's. That's great, man. What are you doing after your bachelor's? Are you continuing on to other forms of education? Or are you getting back in? Are you getting into the industry? Yeah, final exams for college must be tough. Ideally, both. Word. Lifetime learner. I like it. That's I am master's plus part-time. That's great, man. Keep it up. Do it. I think one of the things that bugs me the most about my past decisions was like not finishing college. It's not always easy. Unfortunately, I ended up getting a job without having a degree, but I would certainly love to have that bachelor's degree under my belt. So stick with it. Stick with it. It's a good thing to have. It'll help you. It's a lot harder to find jobs and get good pay without it. Welcome everyone else. But yeah, I appreciate you, Johnny. Thanks for always hanging out, and thanks for that for the sub as well. No degree at all? Why? Well, it's complicated, but it boils down to money. I didn't have the money to finish the school that I was in, the degree program I was in. I made it halfway, and then couldn't pay tuition any further. So then I dropped out. And I would have had more money from grants and whatnot, but I didn't go originally to the school I wanted to go to. I went to a different school because the girl I was dating went to that school, and so I changed the school, the university I was going to go to, because of the girl I was dating. And then, like first semester, she broke up with me. And then I was like, what the fuck am I doing? And so I dropped out of that school and went to the actual school I wanted to go to. And then by then I had already blown through all of my grants. So I, got whatever financial support I could. But yeah, in the US, you have to go into debt generally if you want to go to if you want to go to most schools, honestly, I was going to say good school, but you want to go to most schools, you got to get in debt. So yeah, I went in debt like 30,000 and didn't even get a degree. But fortunately, open source, I was already doing open source work, and that allowed me to find a job. But yeah, take advantage, of the fact that you don't have to pay extra to go to university, because not everyone has that. As fucked up as it is, it's common here for people to have to go into debt, I don't know, $20,000 to $100,000 to get a degree. Yeah. So today we let's see. Last time we were doing some AOT stuff. I don't remember what we were doing. We were doing. Oh, we were trying to make the static runtime. Right. And we hacked it together, and we very nearly had it, and then it crashed when I started. It wasn't until later that I realized what that crash was. We just didn't initialize the runtime. But anyway, in the I gotta respond to this. So universities are expensive. Yes, they are. It's super fucked up for sure. And then your thesis supervisor sent you this. Have you seen? Yeah, COJRS. And then you check the GitHub, Cloud AI. Yeah, did you have any other thoughts than that, Johnny, about COJRS? Or did you stop it like, yep, Cloud AI? Because I ask, Johnny, because that's also where I stopped. when I saw that project, it's the thing is that in some ways it's cool that we're getting different closure dialects spun up on different hosts because of LLMs. It's easier to just spin up a closure dialect, but in other ways it's not cool because they're not actually like viable production dialects. Like no company is going to want to no sane company is going to want to build their products on a vibe coded closure dialect. There's got to be some amount of like engineering rigor and trust that goes into building a technology enough to where you can then build a business on top of it, and so, well, yeah, I saw one of the things that in the post that for that dialect that showed up in the closure subreddit, somebody asked like, oh, is this like an alternative to jank? And I didn't, I didn't respond, but I'm thinking to myself like, well, I mean, do you consider a vibe coded closure dialect an alternative to jank, which is like I'm trying to make a production closure dialect, if your values line up to where like those two things are in the same category, then I guess, but that's not how my values line up. They're not. Like that's a cool that's a cool toy, you know, that somebody's made. It's like super cool that LLMs can do that. But would I build a business on that? Would I trust that I could go to, you know, approach companies and be like, hey, yeah, you should explore running your business on this dialect? Fuck no. That would be a really, what's the word I want? I can't think of the word that I want. But it's like YOLO. Dangerous, carefree, destructive. Yeah, I can't think of the word that I want, but it's either way, it's a very different thing from what I'm trying to do. And that's all we're going to say about vibe coded Clojure dialects right now. So what I have since the past week, when we were hacking on trying to get the static runtime to work, is that I have a reliable static runtime working, and it's fucking great. So check this out. Let's do a bin watch bin compile J16 on that, and let me do a jank compile. So I'll remove I'll remove target. And then let me do a jank compile with 3 and module path temp AOT. So we have this temp AOT. We have this hello world program here, right? And so we just have this AOT namespace, and then inside we have our main function. And the only thing we're going to do is print hello world. And I am going to AOT compile that with jank to, now normally I want to pass a flag like static or something. I have that just sort of hard coded right now. So this is going to be compiled to a static runtime. And so we'll do this. It completes in, I mean, this is the time it takes to show the prompt, but let's say it completes in about a second, which is great. And what we end up with is this, right now 12, but if we strip that, we end up with a 9.6 meg binary. And if we run it, then here's our hello world, about 85 milliseconds. So this is, if we do compare this to projects, I don't actually know where I put this. I think I put this right here. Hey, thing on one. What is jank? Jank is, wait, is this the right one? No, this is not the right one. Yeah, I don't actually know where I put that. I'm going to give you guys a black screen for a sec. I'll be right back. Projects temp native image hello. Okay, I'm back. Sorry about that. Thing on one. What is jank? Jank is a programming language, which is a native Clojure dialect. And so Clojure is a Lisp. It's a modern pragmatic Lisp that historically runs on the JVM. But a neat thing about Clojure and how it's designed is that it runs on a whole bunch of different platforms, actually. And so Clojure's on the JVM, it's on the CLR, it runs, there's a Clojure for Lua, there's a Clojure for Python, there's a Clojure for Dart. And so jank is the Clojure on the native platform. And the amazing thing about jank is, compared to other programming languages, is that it has interop with C++, and it has like unprecedented world-class interop with C++. So we JIT compile C++, And you can, from your like dynamically typed Lisp code, you can reach right in to C++. You can just in time instantiate templates. You can create stack allocated instances of C++ objects, and their destructors will be called at the right time. You do overload resolution with implicit conversions and default arguments and everything like that. It's anything you want to do from C++ for the most part, you can do from jank. Do you generate shaders and compute shaders from this, or is it CPU focused? CPU focused. So it's basically, jank is, think of it as, jank is a closure dialect, but it's also a C++ dialect. And so you can think about it from either way. You can think about it as either a closure that just bridges the world to C++, or you can think about it as a C++ application that you can write using closure syntax. Either one works, really. Depending on what you're doing, you might think about it one way or another. What does this do in jank? Defin foo dot bar x. Let's see. Without the extra s going on in there. Okay, so we were just compiling that. Let's compile it again here. So we get an error here saying that there's no bar member within object ref. And so this object ref here is basically the equivalent to Java's like object base type. This is jank's base object type. And so X, we're defining here a polymorphic closure function. X is just going to be a base object type. And when we try to do interop here to access the bar member, it doesn't exist. And so we get a nice error pointing at exactly where the error was. We're in a macro right now, which is defin. And so we get some info to say that we're currently expanding this macro. And then info about the types. So jank is basically a dialect of Lisp. It's a dialect of closure, and closure is a dialect of Lisp. So yes, jank is a dialect of Lisp, but jank is also a dialect of C++. Makes sense. C++ doesn't support runtime reflection. That's right, Johnny. So it's important to keep in mind that all C++ interop in jank is statically typed. There's no runtime reflection going on. And so if you try to call a C++ function, we need to do overload resolution on that function call. And so we need to know all of the types of the arguments ahead of time, as well as if it's a member function, we need to know the type of the invoking object, right? And so when you think about it that way, like when you think about jank from a C++ perspective, you can think of jank as like, well, jank is a C++ program, and jank programs are a C++ program, which means they're statically typed, right? But we just use polymorphism in order to achieve like dynamic typeness. But the whole thing is like everything in jank is encoded in C++. So the line between statically typed and dynamically typed really blurs when you start doing this interop. But since jank actually compiles its code to C++, we go from jank code to an AST to a custom IR and then to C++. Everything just ends up being C++ code anyway. Can you add a Discord channel for stream dump? Pasting code snippets here sucks. Oh, I see. Yeah, why not? Why not? There you go. There's a new Twitch stream channel. Feel free to paste things in there. You hang out on the programming language Discord? No, I feel like I've seen Jank before. I do, Octolide. I'm in there, but I'm not super active in that Discord. There's a Together C and C++ Discord that has a language design channel. I tend to be a lot more active in that channel. But in general, I try to not talk a lot on Discord and instead just work on my language. So what I was saying is that we have this static runtime now. And so if I take a look at this binary that's produced, guys, this is super fucking cool. We now have a binary that's produced that we can compile in 1 second that doesn't depend on Clang or LLVM, right? It's not necessarily standalone in the sense that it's not a statically linked fully binary, but it's standalone in the sense that everything that it does depend on is just system libraries that are going to be really easy, to make this binary portable, and that's tremendous. Yeah, I avoid that too. How about the code you just posted on Discord? All right, Johnny, I'll take a look. So the code you just posted on Discord, Johnny, is not going to work. So first off, Jank doesn't support type hints on parameters at this point. The thing is that when you have something like a foo that takes an X, right, and you say like, oh, this is my foo, and my foo is some native C++ type. This works in Clojure JVM because every enclosure on the JVM, every single class type inherits from object. Okay, every single class type inherits from object, and so if X is an object, then in order for you to say, oh, well, this is actually a my foo, you can just cast it, right? You can just say like, okay, so, this is a my foo, and you just cast it. And the JVM will do the necessary runtime type information checking in order to do that cast for you, right? But in C++ and in C, there is no base object type. For all types. Like if you make we can do inline C++ in Jank. So let's say I make my own foo here, right? And I give it a standard string name. Okay. So here, my foo doesn't have any base type. There's no common way that I can refer to this thing without throwing away all of the type information. So if I have like a pointer to void, which just throws away all type information, and this is a pointer to something, then I could point at this, but you can't just like pass it arbitrarily into a Jank function because Jank functions work on Jank objects, and so then we end up with like some more difficulty when it comes to passing these things around. Octolite, did I get rid of the runtime too? So no, in the static binary, we have statically linked the Jank runtime, and that's why it's going to be pretty chunky. This is 9.6 right now. This is without LTO. So with LTO, we should hopefully be able to trim this down quite a bit more. But yeah, all of this comes from having the whole Jank runtime in there. The main thing about this static runtime target of being able to take a Jank binary and compile it down, or Jank program and compile it down to a static runtime binary, is we no longer depend on Clang and LLVM. and instead we just bake in everything that that you need in there. Meant, did you replace the libc runtime with a native one? No. I mean, we don't want to change the native runtime. Mainly, I'm just trying to strip away the all of the like Clang LLVM JIT compiled stuff and try to get us a normal looking native binary. Let's see, Johnny. So you basically have to consume it inside of a function and make sure it's the correct type. So it's just general ideas happening. Jank is running LLVM translated to IR. Okay, so let me tackle each of these questions. These are interesting questions. So, Johnny, if you wanted to pass something in, if you wanted to pass a myFoo into this foo function, then here's what you could do. So you could say, you could do something like this. So we have this unbox, and so we're going to use a myFoo, and then we're going to do X. And now I could do a print line of .name on myFoo. And then here, if we call foo, let me double check what you had. You said a top level let. That's fine. So let's do a let here, and we'll do myFoo, and then we'll do a CPP box, and then let's actually create a myFoo here. So we'll do a myFoo, and I'm going to construct this with a C string literal, which is full case meow. And then this will just end up being like a myFoo pointer. And then we're going to grab the address of myFoo. So myFoo is a stack allocated value here. And so this would just be like making a, like in C++, if you just said myFoo, meow. Like these two lines are equivalent. And so we'll do the correct overload resolution in order to find the, we'll do aggregate initialization because there's no constructor here. And then we'll take the address of myFoo, and that'll give us a pointer to myFoo. And then what we'll do is we'll create a box. And so this CPP box gives us an opaque box, which is a jank object. And I'm going to call this myFoo pointer. And myFoo pointer. And then what we do, this opaque box stores a pointer to a void. That's that completely type erased pointer. But it also stores the actual type because we know the type when we box it. And so it stores the type inside of the box. And then when you unbox it, we verify that the type that you are trying to unbox it as matches the type that you originally boxed it as. And assuming that all that goes well, then we, so let's just do a jank run temp AOT. There's no member name in foo. Why is that a problem? So the problem here is I tried to call name instead of accessing it. There we go. So this works fine, and we end up printing meow. And what we end up doing here is just trying to turn this into a jank object by creating this opaque box. Now, the really fucking cool thing here, is let's assume that we have a myOtherFoo. Because like if I just change this to be like a pointer to int, right? Then that's not going to compile because we're going to try to access the name member, but there is no name member on an int or a pointer to an int. But if I try to unbox this as a myOtherFoo, and myOtherFoo also has this name member, so we will compile. But the thing is that this is not valid at runtime, right? Because we end up creating a myFoo here, and we box it, and then we try to unbox it as a myOtherFoo. That's a different type, And so this is going to fail at runtime, but check this out. The failure that we get at runtime is fucking gorgeous. So it says this opaque box holds a pointer to my foo, but it was unboxed as a pointer to my other foo. And then you get source information for, oh yeah, and it was boxed right here and it was unboxed right here, which is gorgeous. And if these are in different files, then we're going to end up showing two code snippets here for different files that say it was boxed here and is unboxed here. And so opaque boxes, they keep information not only for the type that's inside, but they also keep information for the source information for where the boxing and unboxing is happening. And that way we can provide really good error messages when you try to do this sort of thing. And then Thangon, you were asking, Jank's running on LLVM, and then translate to IR and the machine code, and then Jank's relation to C++ enclosures being a dialect of both. Yeah, so Jank uses LLVM and Clang. Jank lexes, parses, analyzes closure code, and then it also hooks into C++ analyzing because it Jank hooks into Clang's AST. And then Jank's AST and Clang's AST just sort of work together. And then we go to our own custom IR in order to run some optimization passes that work at the level of closure semantics. And then we lower down to C++ code, which we either give to a Clang JIT compiler, or we AOT compile. And so Clang will take the C++ code, turn it into LLVM IR, and then give it to LLVM to optimize it, turn it into machine code. Wholly living up to the name. Well, the thing is, like, I was showing this in previous streams, but in order to do interop with C++, like, languages don't have good C++ interop because it's fucking tough. C++ is crazy and is not designed to be interop with from another language. But I really want a dynamic language that can just reach right into C++ and do everything that it needs to do, everything I want it to do. And so, that's why we have this. Clang doesn't have a stable API, Johnny. Neither Clang nor LLVM have stable APIs. They break every 6 months with every release, and it's a real pain in the ass. Which is why Jank vendors its own Clang LLVM. God, I've always hated the syntax style, but that embedded CPP is cool. You mean the Octolite? You mean the Lisp syntax style? Also, hey, Sorcerer. I didn't miss your message. I saw you. Jank does have a Discord. Maybe if some helpful folks in the chat would drop a link to the Jank Discord for Sorcerer. Thanks, Johnny. Yeah, Lisp syntax, never get behind. It's pretty amazing, honestly. It takes some effort to look past, but being able to work with your code structurally, people incorrectly say that when you're working with Lisp, you're working with the AST. That is not correct, because that's not what ASTs are. But you are working with the parse tree, and that is pretty badass. And especially in something like Vim, it works really well because Vim has the notion of text objects. And text objects then, like with just a helpful plugin, can be taught to operate on the level of Lisp's parse trees. And then it's just, the structural editing just becomes so pleasant. So pleasant. Yeah, people either live or die by it. You're right. You're right. Okay, so now that we're warmed up and we've done our foreplay, we're gonna jump into actually implementing something today, and I'm gonna do some coding instead of just showing off what we're building. But I'll also be doing a bit of showing off, and you're also still welcome to ask questions. Will there be a need for dedicated LSP for jank later on? Yes, thing on. Jank's LSP is going to need to handle Clojure stuff, like basically all of Clojure LSP. But it's also going to need to, like, if we want it to be great, which it must be great, then it's also going to need to handle all the C++ side of things. And so I want to be able to get like code completion when I we were doing this stuff. If I have a pointer to my foo right here, which is this is what this syntax is this is a C++ DSL syntax for referring to C++ types. You can do all sorts of shit in here. In fact, let me show off a bit about what you can do in here. So we have a jank book, and if we take a look at the C++ DSL, so you can take a type, you can add a pointer to it, you can add a reference, that's an L value reference, you can add an R value reference, const signed, long, you can create arrays, function types, you can instantiate templates, and then you can have member types, pointers to members, pointer to member type, as well as pointer to member values. And so here, if you wanted like a standard map of standard string to pointer to int, then you can instantiate the template of standard map with standard string and pointer to int. If you wanted to reach into a member of standard array of char64, then you would instantiate the template standard array char64, and then you would reach into the member and grab this value type. And so we have all sorts of stuff for arrays, and here's a fun one of like, this is a pointer to a function that takes in a reference to const standard string and returns an integer. So here's you take the function type first, then you get a pointer to it. So here's a function type where the parameters, you have one parameter that's a reference to const standard string, returns an integer, then you get a pointer to the function type. So yeah, you can do all sorts of stuff with types as well as C++ values using this DSL. What do you think of my language? Our philosophies are so different, you'd probably pick out things I never thought of. What's your language, Octolite? Be interested in contributing and knowing more about the code base? What would you recommend to get to know jank more other than reading the jank book, reading the current code base? If you know, like modern C++ and you know Clojure, then you should just be able to read the jank book and read the code base and jump in. If you do want to help out, then feel free to join the Discord or the Slack and ask me questions. Happy to help. Mock is a statically typed compiled systems language designed to be fast, simple, verbose, and intuitive. Simplicity, explicivity. I don't know if explicivity is a word. Maybe it is. I don't think so, but it works. That's the way English works, is that like, I know what you mean when you say that. And so why not have it be a word? Okay, so and then here's AI stuff. Okay, so, or not AI stuff. Here's the usage stuff. I was thinking AI because I was like, oh, it's nice that this is not like covered in emoji for AI. Okay, so use standard runtime. Use print from standard print, presumably. Use, is that Ruby? Is that syntax? Is it Ruby use that I was thinking of? That Ruby has, no, I mean the syntax for use. Unfortunately, searching Ruby use doesn't actually give me what I want, but fun main. So this main symbol is dealing with how you want this symbol to be exported. Controls monomorphization. Why would main be monomorphized? It's already using complete types. Yeah, this is kind of like, well, the thing is, so one thing, Octolite, is that your examples don't give any idea of, this is not a fault of your language, because I don't know this, but it is a fault of the examples here. They don't give any notion of what memory management is like, which whenever I look at a systems programming language like Rust or Zig, or Odin, like other newer languages, I want to understand, like, okay, so am I manually managing memory? Is this handled for me, either by a garbage collector or by borrow checker or whatever? Okay, so it's entirely manual. And then when it comes to memory safety, if it's entirely manual, then is there anything that prevents like double freeze or anything like that? Or is this just entirely up, C style up to the user to make sure they do it right? Zero safety at all by design. Yeah. I hear you. Yeah, I mean, so the languages that we're building are just drastically different, right? Like Clojure is not a systems programming language and never will be, even though we have a C++ runtime. They're just so drastically different that they're not even competing. But I do like the type of language that you're going for, and part of me wants to build a language like that too. I wanted to get your reaction since they're completely different. Yeah, so part of me wants to build a language like that too. I see the appeal of something like Zig. Like we, in fact, on a previous stream two weeks ago, I think we were watching an interview with Andrew Kelly, because I really respect Andrew Kelly and what he's doing and what Zig is doing. And I get Zig vibes. I get Zig and Go vibes when I look at your language, Octolide. That doesn't mean it's right. but maybe that's what you're going for, maybe not, but it's the vibe, it's the type of vibe that I get. And I appreciate those vibes, like I think what Andrew Kelly is doing with Zig, especially with regard to like making data-oriented programming easy, right? The Mike Acton style programming, like making that easy and giving people the tools that they need to do that both easily and reliably. And then not only that, but Zig also builds a kind of development philosophy. There's a culture around doing that type of programming. Zig very much is designed around like, this is for people who want to tell the CPU what to do, rather than people who want to work at a high level semantics of transforming data, which is actually what Clojure devs do, right? We're not thinking about how this is laid out in memory. We're just thinking about like, oh, what are my data shapes? Let me write some pure functions to transform that data into different shapes, and then rely on the runtime and the garbage collector to handle the rest. So very different styles of programming. But part of me, especially since my background is in game dev, part of me really appreciates that sort of systems programming Zig style, oriented around simply telling the CPU what to do. So yeah, I like it. Keep going. And also, don't listen to me. I'm just a jabroni making a lisp. Can you get a link to the Slack channel for jank? Yes. Here is a link to, wait, is that right? Here is a link to the Slack server, and then it's just the jank channel in there. Unfortunately, I can't link you directly to the jank channel if you don't already have an account in the Clojurian Slack. You know what I'm saying? Yeah, doing everything from scratch is impressive, Octolide. I respect that as well. I think that I like the idea of that as well. I like the idea of implementing something like that. I hope that I can get to a point where, for a toy language, not something I want to like use in production or try to get other people to use, but I would like to try my hand at that as well. For jank, I don't think it's viable because we rely so much on Clang for JIT compiling C++, as well as Clang's AST, so that we can use the compiler as a library in order to do all of our seamless interop stuff. But for a Zig/Go-like systems language, absolutely, yeah. I mean, that's kind of the best language for doing your own backend, your own compiler backend. Makes sense. Okay. Now, now we're going to get into this static runtime. I want to show you guys what I want to do. So I have, no, you're good. You're good, Octolite. I get like this every stream where it takes a while to finally get into what we're going to do. But we're all having fun, and that's what we're here for. So the main thing here is, and I have some numbers. With Clojure, you can native image hello. Hello. Where did that go? Yeah, this is, oh, I made a native image examples. I wouldn't, so I had to clone, because trying to find out how to do this shit in Clojure is so annoying, because the Clojure CLI is such a bad user experience. But here, yes, okay. So we have target, hello. We have target native image, hello. God damn. Okay. So basically what this is a Clojure program that does the same thing, right? And so the Clojure program here is just a normal Clojure JVM program. And then I use line native image, this guy. I use line native image in order to compile this to a Graal native image, which is basically, that's the static runtime, right? So jank's static runtime is equivalent, it's analogous to a Graal native image. And so I wanted to compare, okay, how big are the native images from Clojure JVM, and then how long do they take to start up? And so if we do a target native image, hello, so we can see they're 15 megs. And then when you strip them, they're still 15 megs. Okay. So jank stripped is 9.6. This is without LTO. So like, I think we can still trim off quite a bit from there. And so they're quite a bit smaller, which is great, because I want jank's binaries, static runtime binaries, to be smaller, and I want them to be faster. But when it comes now, jank's static binaries will be faster, at least for the benchmarks that we have, than Graal native images. But when you just measure startup time, they're not. Graal native images start up in 6 milliseconds, but we're taking 82. Now, I did some profiling to figure out where the bulk of this time is being spent, and it's being spent reading meta. And so what we have is all of the metadata from Clojure Core, we end up code generating as strings. And then on startup, we do basically a read stir. So we lexin, we parse those strings into Clojure data. And that is where we're spending this 70 milliseconds, is just reading Eden data into actual like heap allocated Clojure objects. And so this is an example of, if I just remove the reading of all of the metadata, then we can get this down to 12 milliseconds. I don't care about hitting 6 milliseconds. Like, if we're under 50 milliseconds for, across the board, then it's instantaneous as far as the user is concerned. I don't care if it's 12 or 6 milliseconds or 20, but 82 is higher than 50, which I choose as my, as the limit that, the threshold I want to be under. And so my goal here is to shorten this. And I've tried it the past few days, different approaches to try to see how I can do this. The first approach that I did was that I tried to, rather than encode this as strings and then do a read string on it. Hey, Illusionary Moon, welcome to the stream. I tried to just encode all of this metadata as C++ functions, and that allowed us to drop the startup time quite a bit. I don't remember maybe it was 20 milliseconds or something like that. So like, it definitely went down quite a bit, but it exploded the code size and the compilation times. because there's just so much code that you need to generate to create the thousands, tens of thousands of maps, for all of the different metadata, for all of the different vars and all of the different functions and all the different objects that have metadata. And so I want a different approach. Now I tried optimizing that metadata in different ways. Like one of the things the last thing I tried doing was, so we lift globals, we lift constants into globals, but these metadata maps they're often just source metadata. So we have like a source file and line and column, offset information. And so these maps all have basically the same keys. And so what I ended up doing was like I walked all of the different lifted constants in order to extract all of the common bits out of them and then lifted those. And that way, when we go to construct those maps, we can just reuse existing values rather than needing to re-intern all of those keywords again, everything like that. This shrunk the generated code down quite a bit, but it was still just far too much code to compile. And so I think that trying to represent all of this data in terms of C++ code is just not very viable. And so today I was considering like, okay, what can we do, right? Worst case, I can just say, well, we have a working static runtime, takes 82 milliseconds. In terms of getting the language launched and everything, that we could definitely launch with that. It's not a blocking issue, but I would certainly like to perform better in this regard. And so I have two ideas for what we can do. And the first one, which is the one I want to try now, is to lazily read our meta. So this should, in practice, and certainly for the testing of our hello world, it should mean that we can basically just not read any metadata, because we don't really use metadata much at all, except for like error reporting. And, occasionally some application code will depend on some metadata, but we really don't use it much. And so we're paying the majority of our startup time, 70 milliseconds, versus 12. We're paying the majority of our startup time for something that we're not even going to use. For most applications and for most like portions of most applications as well. So even those applications that do use meta, they don't use it for the bulk of their application. They're only using it in a couple of places, right? And so it doesn't make sense to like front load all of that parsing of the metadata. Why not just do it lazily? This is how we handle JIT compilation of functions as well. By default, if you do a jank run on some file, and we find a whole bunch of different, we'll load your file, and your file requires a bunch of other files and whatnot, a bunch of different functions in there. We're not going to JIT compile all of them right away whenever we see them. Instead, we're going to do the work that we need to generate the C++ for them, and then we're just going to hang on to that C++. And then we're not going to JIT compile the C++ until you actually call that function. And then we'll JIT compile the C++, and then we'll replace the function object with the JIT compiled function object. And so next time you call the function, you'll just call the actual JIT compile function. But this allows us to, for example, cut the compile time of Clojure Core in half, because half of the functions we don't need to compile. So I think we can do the similar sort of thing with meta here, but that's going to require going through all of our objects and changing the way that we handle meta to where instead of just being an object ref, which points at a map, generally a persistent hash map, instead we're going to need some lazy meta type. And that lazy meta type is either going to store a string, which resembles some yet to be parsed data that we need to load in, or it's going to have an actual object ref for the map that we want. Hopefully all of that makes sense. So yeah, I don't know. My guess is that we can, like, there's going to be some overhead in creating all of those lazy meta things, but my guess is that we can probably get under 20. That's what we're shooting for. But under 50, as long as we're under 50, I think I'll be happy. So let's take a look at how we can actually do this. I'm going to get back. Also, somebody was pointing out, like, C++ is 15 kilobytes versus 9.6 megs or 15 megs. So 15 megs here. This is for the Graal native image. So this is Clojure JVM, and then jank is 9.6. So yeah, I mean, this is the C++ like runtime, right? There's very little in the C++ runtime, whereas in the Clojure runtime and in the jank runtime, you don't just have a main function, you know, that prints hello world. Instead, you have like your whole runtime that manages all of your namespaces, and it manages all of your vars and interns your keywords, and has all of your functions for Clojure core, you know, that and any other namespaces that you bring in, and then all of the implementations of sequences and all of the objects in the whole object model, you know, for all of the different collection types and their sequence types and their transient types and everything like that. And I think it's a lot harder to trim out that stuff, which is why these end up just being larger. So we'll see what we can do with LTO. I'm not there yet. I wanted to tackle the startup time first, and then see what. I mean, there's a bunch that we need to do. LTO is one of them, but hopefully that will be able to trim this down even further. Especially if we can do direct linking, which we don't currently do. That might be able to make LTO even easier. Okay, so in order to let's see. So we're going to need to add a include C++ jank runtime. Let's do like a lazy meta thing. Okay, so lazy meta is going to have an object ref and also an immutable string. Let's call it source. Include jank runtime object. Okay, so what we're going to want to do is we'll just have a get function on this, and then we'll need a constructor. So in the default construction case, we're not going to have a source, and then our meta is going to be nil, and that's fine. Because all get's going to check is source not empty. If source is not empty, then we have to read it before we can return our meta. So if this is not empty, we need to read it before to get our meta. Okay, and then here we will be able to take the source, and then here we'll be able to initialize also with the meta. And so we'll require jank runtime lazy meta, and then we'll yoink that, and that's that, and then here, and then here we'll just do source, and here we'll do meta. Okay. So this is basically how this thing's going to work. The only other thing we need is to implement this get function. And whoops. And so we have lazy meta get. And so here we'll just say if source is empty, then return meta. And then otherwise, we'll return meta here after we do a jank runtime context. So we'll do a runtime context, read string, forcefully read string. Forcefully read string. We don't have a dot clear on that, so we'll just set this to empty. Okay. Yeah. So let's take a look at meta now. I need to remember how we handle meta on our objects because I've been changing things and I don't remember if I've already changed it to be on the base object. No, we don't have any sort of function for that. Okay, so we have meta dateable then. Okay, so metadatable says with meta and get meta. So let's take a look at something like a persistent hash map, which I know has meta. But it gets its meta from this base persistent map. So we have our meta here, and then we have with meta and get meta. I wonder if we already have this get meta function. I don't remember why we needed that, because we don't normally add accessors for things, because we just put things in structs. Generally only if we have a need for doing some work before getting a value do we add an accessor. And so clearly we needed to do that for something. Let's take a look. I want to go into compiler runtime, and then I want to do a get meta on compiler on source CPP. Jank. What do I want? Jank runtime object. And then just step through these. Really great plugin, Vim Unimpaired, for stepping through. This is a combination of two plugins. There was the There's the actual search one, which then puts the results in the quick fix window. And then you combine that with the Vim unimpaired to be able to step through them, step through the quick fix window. And that's the end. So wait, do none of these actually do any work? I don't know why we have get meta. So we use get meta. But the thing is that I think that oftentimes we also just don't use get meta. I wonder how many times we're actually doing something like meta. I need to escape that. Yeah, and so we have like all of these times here where we're actually just accessing meta through pointer indirection. Although not all of these are runtime objects. Like this is a AST expression. Okay, I'm not going to worry about get meta right now because I don't know if we're even going to want it in the future. So I'm not gonna worry about it. What I am gonna do is I'm going to do a grep for object ref meta in how do I want to do this? Yeah, no, that's fine. We can do that. I can do it in here. Get meta. So we'll do object ref meta in include runtime yeah. Okay, so this we're going to change to lazy meta. And this is actually lazy meta, so we won't do that. Symbol, persistent list, native vector sequence, deferred CPP function, JIT closure, opaque box. Hey, we were just talking about opaque box. JIT variadic closure, native function wrapper, persistent vector, base persistent map, lazy sequence, cons, persistent hash set. This makes me realize that one of the things that we're going to need for our lazy meta is synchronization, because the whole runtime has to be thread safe. So we'll need to synchronize that, but that's fine. Where were we? Sorted set, namespace, and that's it. Okay, so save all those. I don't want to build just yet. Now, each of these things doesn't actually know what lazy meta is. So we're going to need to lazy meta. Here. Okay. So this should break any places where we're currently reaching into the meta on objects. And I'm just gonna I need to decide now if I want to use that opportunity to make those meta members private, or if we, and then we can just use the get meta member, or if I just want to call a dot get on all of those. I think I might want to make them private. Let's do that. Privatize. Okay, so this is private meta. Oh, I did that at the very end. Okay, so this is already, oh, that's lazy meta. Everything here is thread safe. And the other thing I need to do is I need to update all of these. See, because you'll notice that there are comments that says like, okay, everything here is immutable after initialization. Everything here is thread safe. And I do this to keep sanity, you know, like what things do we need to worry about here that are going to be changing? We'll put that here. And so these are all immutable, and then this is thread safe. Okay, and then this is thread safe. I don't want to put that after the bool, so I'll put it here instead. And okay. That is immutable. That's thread safe. And then I don't worry about formatting because when I save all of these, it's just going to be formatted for me. Okay. All right, so those are all saved and formatted. Now all of those are going to be private now, which means we're going to have to go through get meta in order to access that. And so now all we need to do is we just need to find the get meta functions, all of the get meta functions inside of the source CPP jank runtime. And in each of these, metadata is actually locked for vars. That's interesting. Because metadata can be replaced for vars, but it's considered to be immutable on... That was probably a hole anyway, because metadata can be replaced on other stuff. Yeah, so this is an all-around improvement, because we're going to need synchronization on that. Okay. But that does mean that we probably don't need synchronization on this guy anymore. So this also needs to be a lazy meta. We didn't catch it because I searched for object ref space meta, but this was a fully synchronized object ref meta. But it's already private. And then, yeah, so all we need to do here is return meta.get. Return meta.get. And then this is a const function. Yeah, so that implication here is that get should be const, because although this does change some underlying stuff, we do want to be able to use this on a const object. Okay, so this is .get, this is .get, .get. I'm not going to say .get for every single one of these, but I'm thinking it. Namespace, okay. And that's all of those. All right. So now we compile, and then we're going to hit some compiler errors for any accesses for meta, like this sort of this arrow meta. And we just need to address those. So persistent array map. Okay, so base persistent array map has this marked private, but we're using base persistent array map as a helper. So we want to jump to this. We want this to be protected. Man, it's been so long since I had to make something protected. I don't remember what it was called. Okie dokes. Meta's a protected member. But we need to access it here. Interesting. So this is where we're registering the offset of certain. No, this isn't in a class. So this is in the initialization code of the garbage collector. We end up registering. That's annoying. We end up registering. Why did the indentation change on these? Okay. We end up registering some types with the garbage collector to describe to what is normally a conservative garbage collector that just scans all memory. We describe the type of these values to the garbage collector so that way it can more precisely scan them. It knows where the pointers are going to be and when they're not, where they're not going to be. And so in order to do that, we need to access the offset of particular members, but we're not able to get the offset of that member when it's protected. That's fair. I think what we'll do instead is we'll go to persistent array map and we will just put the offset of right here. Oh, but this is the offset in putters. All right, here's what we're going to do. We're going to just disable this for right now because I don't want to have to deal with this. So by commenting out the GC descriptor, we end up telling the code that's going to allocate that type that there is no type descriptor for it, and then we just remove the registration for it. And so now it'll just be allocated and marked in the normal conservative way. And then we'll deal with how we want to expose the offset of that member later. Okay. Trying to find the top of this error. Okay, so yeah, seek 1153. And here we are accessing meta. So we want to do a get meta on that guy. And I'm just going to search for this here. There's no such thing. So in meta.cpp, this one, 98, this is saying that there is no set meta. Right. So we've made meta private. And so in reset meta, what we used to do, we get into a bunch of template shit in order to actually implement all of this. But we used to visit the type erased object in order to get the fully typed object. And now we're in a Lambda with a fully typed object. And then we do a compile time if to check if this type is metadatable. If it's not, then we throw. If it is, then we check, okay, well, does it have a meta member that I can access directly? So this is like just straight up asking, you know, can I, if given a pointer to this T, can I just do T arrow meta and get back something convertible to an object ref? Like this is a compile time predicate for exactly that. If so, then we just do meta is equal to meta. Otherwise, we expect that there's a set meta function that we can call. So I think that we just need to add a set meta function to all of these. So let's we're gonna need to do, now do we want to do equals? Also, this should just be void. I'm just gonna do set on that. So we'll add a, because we have a get, we have a set object ref o. Hey, silencioso. ¿Cómo está? And so here we have a meta, so we're just going to set this, and then we're also just going to wipe this out. Hey, been watching you on YouTube for a while. Oh, that's cool. What are we working on? We are working on optimizing the startup time for the binaries that Jank is producing in its new static runtime. And Jank static runtime is like Graal native images, where you're able to bake a Jank program down to an executable that no longer has the ability to JIT compile anything. So it no longer links to Clang, no longer links to LLVM, and it has the Jank runtime statically linked in. And we currently start, it takes 82 milliseconds to do a hello world. And the bulk of this time is spent reading metadata. And so I'm trying to optimize the reading, well, not so much optimizing the reading of the metadata as I am deferring it. Basically making all of our metadata reading lazy, because my hypothesis is that the majority of the time, for most programs, we don't actually need to read all of that metadata that we have on startup. We generally read metadata on like errors, you know, when you need to get source information or something like that. And so I'm just deferring all of that. And this should probably, I'm hoping, get us down from 82 closer to like 20 milliseconds, which I'm going to be pretty pleased with. Hey, John Yu, welcome to the stream. But Silencio, in order to do this, we've introduced this new lazy meta type, which can either hold a source of actual closure data that needs to be read, or the actual object ref to the meta map itself. And then when you access it, you will, if the source is empty, we just return the meta. Otherwise, we read string. To get the new meta, we clear the source, return the meta. And then we're hooking this in, so we need to update all of our existing usages in order to support like all the places where we had meta before. Now we need to use this lazy meta. But I should just be able to use this and then keep yoinking this and then jump into the next one and then change the type and then yoink and jump to the next one and then change the type. Persistent vector. And JIT periodic function. Symbol. And range. Box. Yeah, I know. I hear you, Johnny. Cons. I swear, like a lot of my time when I'm refactoring things is just spent like getting all the types right and having different copies of different functions that have different types. And this is the exact sort of shit that that we try to get away from when we use base persistent map, when we use closure. So I need to actually take the template forward with this one. I need to grab all this stuff here as well. And sequence, well, that's not what I wanted. Lazy sequence. Range. But sometimes it's meditative to just go through all this stuff. Okay, so that was all of the CPP files, but now we need to go through all of the get metas in the header files. So include CPP jank runtime. And here, oh, so we already have a set meta here. That needs to be called O. Love how dynamic Java's class model is. Yeah. You keep saying that, Johnny. How easy it is, how much easier it is to build languages on top of the JVM. I think Rich Hickey would agree. Now I just have J2 here because we're going to have a lot more errors still with the private meta access. And so I don't want to just like start compiling on a bunch of cores and then have to deal with like way too much error output. Okay, synchronization for this guy. That's fine. Silencio, do you think closure should be standardized as have a formal standardization of behavior expected between implementations? I think that we're going that direction, Silencio. Are you familiar with my Closure Test Suite project? because I'm leading an initiative that is also moving in that direction. We are implementing a closure test suite, jank lang. All good. So there are so many different Clojure dialects, right? We have Clojure JVM, Clojure CLR, Clojure Script, Clojure Dart, Basilisk, Babashka, jank, Fel, and so many more. So many more. But it blew my mind when I was trying to implement the Clojure core functions in particular, that there's actually no exhaustive testing suite for Clojure core. And so Clojure JVM had some tests for some functions in Clojure core, but they didn't just have like here's a test suite that actually verifies that all of the Clojure core functions work the way that we want them to work. And so I started an initiative that does exactly that. And we have people who are writing these tests. We already have hundreds of these Clojure core tests, or Clojure core functions tested. I think if we take a look inside of test Clojure, so we have Clojure core and Clojure string currently covered, and then just a file for each of the different. I don't know why the fuck that doesn't drag. A file for each of these different Clojure core bars, right? And we have a particular testing methodology and tools to help with the testing and everything like that. And what we're doing is we're running these tests for each of the different dialects. And so we have already onboarded, we have Clojure and Clojure Script and Clojure CLR and Babashka and Basilisk and Fel and jank are all running these test suites, but there are other dialects that are not even listed here that I know are running this test suite as well. And so they use it to find bugs, they use it to find differences, and then ultimately they use it to ensure that their dialects are behaving the way that other dialects behave. And so this is the sort of the first time that we've had any notion of like a conformance test suite for what it means to be a Clojure dialect. But from this and the discussion of this last year at the Conj with Rich Hickey and the Clojure core team, when we were talking about this and sort of getting Rich's input and the core team's blessing on this whole thing. And then I was also trying to get other dialect devs to basically own up to saying, yes, we are going to get, our dialect into this test suite. We're going to handle all the bugs that show up, everything like that. Rich started talking about making a specification for Clojure and how like Common Lisp has one and everything like that. I don't think it's something that Rich is going to do, but I think it's probably something that is going to happen. So I think we need to figure out like who's going to do it, how we're going to do it. But it does seem like we're going that direction, Silencio. Does seem so. And I think it would be good. I think it would be good to have. There are obviously some things that need to be left up to the dialect, and that's fine. Those things can be implementation defined, right? What is the difference here? We'll discover special forms, object structure, etc. Yeah, I mean, special forms, absolutely. Syntax, yes. As well as the various different semantics and rules of things like macro expansion. when it happens, how often it happens, ordering of evaluation, and so on. Yeah, I think there's a lot that can be covered, but I also think we're going to be surprised at the amount of things that we're not able to standardize on, because different dialects do things differently. Like ClojureScript, for example, is one of the official closures, doesn't have vars, as far as I know. They just use JavaScript globals. But like a var is like a central fucking concept in like every other dialect. Okay, so we just haven't actually saved this set shit yet. And so while we're doing that, you agree that Clojure doesn't have an extensive Clojure core test suite? Well, it does. I mean, in the now that we have the Clojure test suite being built, it does. Also, if any of you are interested in helping out with that Clojure test suite, please do. We're looking for more people to write those tests, and we have a doc. We have a doc on like how to actually write them, and so it kind of helps you through the methodology of how to think about the tests and what to try to test for. This is writing a good test, but there's a bunch of stuff in there as well about like how to actually use the tooling to get you set up and everything like that. Yeah, I was really surprised, Johnny, when I was, because the thing is like, I can't have confidence in my code unless I have written tests that run continuously that verify that the code does the shit that I want it to do. I don't know. Call me weird, but it's kind of like that. and so there are like over 500 different vars in Clojure Core, and I'm like, okay, I want to implement all of these, and they all have their own edge cases, and they handle errors differently, and they have different arities as well, that transducers and not transducers and variadic, and I'm like, oh well, I want to make sure that like I handle all of these in the way that they need to be handled. So surely there's a test for the test suite for this, right? Nope. We have the same problem with nREPL, right? So we have an nREPL server now in jank that's written in jank by Kyle C. And so I wanted like a conformance test suite. How do we know our nREPL server is behaving properly? And how do we know it's going to handle all of the different clients that people have, aside from just like having people try it, and then if they have any issues, then hopefully they report them. And so I was asking the nREPL folks, like, is there a test suite for this? Nope. They are working, last I saw though, with the help of Technomancy, they're working on a specification for for nREPL, the protocol. And I would hope that after the specification comes a test suite, and that would be great as well. Like all these things are great to, specifications have pros and cons, but test suites are just great. That's my opinion. That's the Leiningen guy. Yeah. Phil Hagelberg, Technomancy. He's a really cool guy. I like him a lot. Okay, I need to add synchronization to this. So I'm going to put these in a struct. I'm going to call state. And then I'm going to do a poly synchronize state. Technomancy is awesome. CS Fennel project. Yeah, so Technomancy is the great shout out sorcerer. Technomancy is the maintainer of Fennel, which is the Clojure-ish like language on top of Lua. Okay, so for here we can do state.wlock and then locked state. Okay, and how am I always late to everything? Late to Clojure, late to C++, Clojure dialect, late to Clojure test suite. What are you talking about, man? You're not late. We need help in that Clojure test suite. Jump right in. And you're not late to Clojure either. You're not late to jank. Jank's not even Jank's not even production ready yet. We'll have a beta launch probably at the end of the year or like maybe January, where we should be at a point where like everything you want to do using jank as a Clojure, you should just be able to do. But it won't yet have enough battle testing for me to call it production ready. But it'll be at the point where like I'm just going to say, okay, everybody, you need to start building stuff in jank so we can find the issues. Because until we do that, then I'm not going to have the confidence that it's that it's production ready. Set meta does not match any. What's the difference? Oh, it's not const. That was the difference. Right. This should not be const. Yeah, Fennel's pretty sweet. I think a lot of people are using Fennel for configuring their NeoVim. I believe it was Olacle, the guy who made Conjure, who made a project called Aniseed, or Aniseed, which is a play on Fennel, and that makes it's a NeoVim plugin that makes it easier to just write your configs in Fennel, rather than having to like do the process of Fennel to Lua ahead of time yourself. I don't actually use that, but it's cool. Yeah, all cool. Bridges the gap between Fennel and NeoVim. I get it. I get it, Tim. I get it. Yeah, I think you're right that Conjure is partially, at least partially, maybe primarily written in fennel. Really wonder if the Claude AI Clojure dialect on top of Rust is going to get accepted. I mean, what does accepted mean? Do you think, Johnny? Like accepted into broad use in the Clojure community? I forgot that we have this meta validation thing. And support of the Clojure team? I doubt that. Yeah, I am skeptical, Sorcerer. Skeptical is the nicest way I can put it. Yeah. I'm also in the how about no camp? But I don't know. Maybe we're gonna be left behind. Us old farts. Sorcerer taken over by the wave of the new young hip vibe coders. It is scary, Johnny. Yeah, if I can't find employment through working on jank, and I need to, and let's say I need to get back to like making money again. I don't know. I would probably just do management. I like some aspects of management. All right. Native function wrapper. 32. So we need a dot get followed by a dot get. We need a dot get. Right. We need a get meta. JIT function. That was 33. I'm going to step away for a sec, use the restroom, and fill up my water. Reminder to all of you to stay hydrated. We're back. So, sir, you went to BA Lisp because the steel guy was going to be there? And also to see what the FSET guy did in the Common Lisp community. Yeah. Oh, cool. So you met up with Matt, the steel guy? JIT variadic function. Yeah, that's the thing also, is that there are people who are just trying to jump into the deep end, right? And they don't know enough to know how they should be guiding the LLM. Pretty exhausting to talk about all this LLM stuff all the time, man. That's that. I don't remember the term now. Was it like AI fatigue? Right, that's what it was. Exhausting, scary, real. Yeah. Matt's cool. He actually, I mean, Matt hangs out in here, not uncommonly. But yeah, I follow what he's doing on Steel. Very cool work. I got a lot of respect for Matt and his work. I haven't met him in person yet, though. That's cool that you did. Persistent vector 180. So here we just need a get on that guy. And should be fine. Okay, persistent list. So yeah, now we're just working through all of the uses of meta, and updating them as needed. So this will slow down meta access because now we have synchronization behind meta, but we need that anyway. So that's okay. 313. The other thing is that like when you do things like pop or conj on a vector, and we make a new vector, we're currently realizing the meta in order to make the new vector rather than passing on the lazy meta. That's something that I'm just doing because right now we have those constructors that take in the normal meta. And I don't want to go in right now and add all those constructors and change them to take in lazy meta instead. But that is something that we could do to further make all of this stuff lazy and have it keep staying lazy as the data structure changes, but the meta doesn't change. So that's a future thing. The irony, D309, is that Johnny's actually ChatGPT. I'm sorry, Johnny, I didn't mean that. What is this? November name GC descriptor in array map 14. Yeah, we commented that out. You're absolutely right. I'm sorry, Dave. I'm afraid I can't do that. Persistent sorted map. Have you seen the movie, Johnny? Persistent sorted map. It holds up pretty well, honestly. My wife and I just rewatched that recently. Yeah, honestly, that's it. That movie hits differently. If you watch it in 2026, that movie hits differently. Wow, persistent hash map 149. Persistent hash set. Speaking of AI, the Clojure Conj call for presentations closes in 4 days. And I've submitted 2 proposals. One of them was a talk about jank that is going to go over all of the... I've never done a technical talk on jank like that actually shows off all the cool features. And so this will be that. And we're going to talk about the C++ interop in detail, and AOT compilation, and the build system, which I haven't even shown you guys the new build system we have. I'm not even going to get into it now, maybe next time. But we have this whole awesome new native build system for jank projects, not for jank itself, but for jank projects to use. So that talk would just go through all that. But I submitted another talk about the philosophy of code. And how I see code as art, and code as something to celebrate, coding something to celebrate as human expression, just like painting on a canvas. And my comparison of software engineering to other artistic endeavors and other artistic careers, compared to also engineering careers, and how this, I think, little uncommonly mentioned fact that software engineering is partially engineering and partially artistic, and how that addresses like a lot of the common things that we see, like editor wars and language wars and all of these like opinions and passions about like the right tool for the job, and how all of that comes from the artistic, like subjective human side of things, and not from the like engineering side of things. And so I propose both of those. But as we talk more and more about AI every single day, I just wonder if maybe I don't want to do the second one. Like, which is ironic, because I felt like I wanted to do the second one because I wanted to sort of give, people talk about this all the time, and they say, oh, code doesn't matter anymore. You can do this in any language you want now, blah, blah, blah. I think we should use set meta on this, right? Yeah. But in my opinion, code absolutely does, the language matters, because we're not just writing code, we're not just creating products. We're creating forms of human expression. That's what those products are. And like you can use generative AI to create paintings, that doesn't make you a painter. And those paintings might be worth something to somebody, but they're not the same as a painting by Rembrandt, Like you can generate classical music with AI, but that doesn't make it Chopin, that doesn't, and it's not the same as somebody who's actually like a composer who writes their own symphony or prelude or whatever, the piece is. Which of those two talks would you guys prefer? If you had to choose one for conj next, conj in 4 months. Get meta. It's tough. Yeah, the build system stuff is so cool, man. All right, let's take a look, Johnny. Yeah. Sort of the other way around. I see it. I see what you did there. Okay, so now we're in the analyzer. And 4. So we're gonna grab meta source. High hopes, cross compilation, better tooling. Yes. So we don't have that right now yet, Sorcerer, but what we have is a really good start. And this was just merged in this week. And the work was done almost entirely by Kyle. Again, the guy who made our nREPL server as well. But what we have is a cargo-like experience for those of you who have used Rust. And that means that you just add a dependency and then you do your line run or your line, build whatever, to build your project, run your project. And then we'll automatically build your dependencies. And if your dependencies contain native stuff, then we'll build those. And there are custom like jank build scripts in order to run those. And we run those in a sandbox as well. But yeah, we don't yet have anything for cross compilation. And my goal is to build on top of what Zig has for that. We just need to get there. I probably won't get there. We probably won't have cross compilation like that this year. So I probably won't be able to show that off at the conj, but we'll see. Maybe Kyle was looking into Zig stuff yesterday. So maybe if he can figure it out and make it all work, then that would be amazing. But I don't expect that we'll get there. Okay. Sorcerer, you've made your choice. That's good to know. So one of the things that I think about that is like, basically everybody, it feels that way to me anyway, that basically everyone's going to have their own sort of philosophy for for this sort of thing, right? So I was thinking to myself, like, who gives a shit about mine? Why would I feel like my opinion matters here? It's already in. Okay, what are we at? What did I miss? A semicolon? A semicolon. I do wish that more people thought about code as art. You know, let me spoil a bit of this, right? I don't know if I'm going to do this talk anyway, but like, what is engineering? Okay, so I've gotten into this before with somebody because I've had like people, mechanical engineers and whatnot, scoff when I say I'm a software engineer, because they're engineers and they're licensed engineers, whatever the term is, certified engineer, and there's like formal requirement for that. Whereas software engineers, anyone can go to a boot camp and call themselves a software engineer. But my defense is like, okay, so what is engineering? And if you take a look at the definition of engineering, it is practical application of scientific knowledge. Okay, so what if we define this, right? So the application of scientific and mathematical principles to practical ends, and let's take a look at my favorite dictionary, which is the Webster's 1913 dictionary, which I don't have. I normally have bound to a bookmark in Firefox, but again, I can't use Firefox in this nested thing, which is why we use Chromium. But let's define rigor is the biggest difference. Yeah, for sure. For sure. And I mean, it would be silly to claim otherwise. So originally, the art of managing engines. This is the Webster's 1913 dictionary, which is such a great dictionary. In its modern and extended sense, it's the art and science by which the mechanical properties of matter are made useful to man in structures and machines, the occupation and work of an engineer. Such a different, that's such a different definition than what we were getting before. But yeah, I think that, practical application of scientific and mathematical principles, right? So let's define like, what is art then? And we'll check here. What is art? The noun. The application of knowledge or power to practical purposes. Wait, wasn't that engineering? System of rules serving to facilitate performance of certain actions. Systematic application of knowledge or skill in effecting a desired result. Isn't this engineering? Also an occupation or business requiring such a skill. The application of skill, the production of beautiful by imitation or design, or an occupation in which skill is so employed as in painting or sculpture. So basically, this revelation here is that like there's such an overlap between art and engineering in terms of skill, and I will go so far as to say, like, if you have any sort of like, my own definition here is if you were to take engineering in any form, and you were to add creativity to it, then you have art. That's to me it's that simple. And I think a lot of people don't think about software engineering as an art form, and I think that that's a shame. Oh, I can't. That's not going to help us. That doesn't help us because lazy meta is private. Okay, so this needs to. This needs to be get meta. Yeah, the UB for the double underscore. Yeah, that's an old one that I've yet to change to a single underscore. But you are absolutely right, Johnny. Ooh, Clang compiler crash. Nice. We're just gonna try that again. Hopefully that doesn't happen again. I think the thing about the medium of code is that it has the more breadth than almost any other medium. It could be engineering, could also be a mere doodle. That's a great point, Sorcerer. I like it. I really like that. If I do that talk, Sorcerer, would you mind if I use that point? Nice. Just made a note. In fact, you insist. I will make sure you get attributed as well. Yeah. I mean, I don't know if I'm going to do either. I mean, I don't know if I'm going to do either talk because I don't know if either one is going to be accepted. So we'll see. It'll be up to the Clojure Conj administrative folks to choose which talks they want. I don't know if they're going to want something about, Jay's philosophy on code as art. Maybe. It is somewhat, it's somewhat similar to what my talk was last year. Which is kind of the philosophy of sticking with your projects. Yeah, I never made it to Strange Loop, but I wish that I had. Yeah. I like the philosophical discussions as well. I think it's a lot of talks are just sort of surface level practical stuff. We built this thing. We ran into these issues. We fixed them. Like those are great talks, but I also wish that we had, I also wish that we had some more philosophical talks in there too. Hey, Vanished Out, welcome to the stream. A good day to you as well. All right, should be good there. Oh, okay, we're almost done with this. Man, this is the thing about like C++ in a non-trivial code base. Like, I mean, Jank's code base isn't even that big. It's 50, 60,000 lines, but trying to make this change and then like I just spent 2 hours dealing with like all of the various bits and bobs and making sure everything's moved and lined up in the right place and everything. And then we get to test whether or not our change actually works well or whether it crashes. Who knows? Who knows? That's an instruction. All right. Evaluate. We're close. So we're going to want probably, this is 284. We need a get meta here. Oh shit, we're linking things now? Love that. I would say I can call a project fairly large when I've rewritten something 10 times to work nicer than other parts of the project. The difference from AI generated code that it spits out the complete thing and there isn't really any philosophy why a tool is built a certain way except the AI wrote it that way. Yeah, I think that some people are more into like micromanaging their AI to say, no, don't do that. Do it like this. Oh, we got linker errors. Undefined reference to lazy meta get. Okay, so yeah, we added a new lazy meta file to the runtime, and we did not add it to CMake. So that is totes magoats understandable. Okay. And now we actually have issues compiling the lazy meta source because now we're actually compiling it, and member source does not name a blah 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 blah. Why? Oh, because it's state. Oh, okay. So state source. Can we do that? Can we do this? Okay, why can't I assign this? What does this guy return? This guy returns an object ref. Why can't I assign an object ref here? Because this is mutable. Muable. All right. Hopefully that gets us what we need. Oh, the formatter did some I don't know, crazy shit with this. Like it puts the closing on the same line as the, I don't even, man. That's Clang format. That is Clang format. Okay, so I'm going to crank this up now to 16. I never use AI just to get things done. I want to understand it, make it simple, and in the end, I use it as just another useful tool to catch some bugs or give ideas. Well, I say, partner, stop it. Okay. If you say so. What if that's just your voice now, Johnny? And every message you send in gets read in a old Western cowboy voice. I can't commit to that. I don't have the brain power for that. Are you maintaining the flakenix in the jank repo, or is that from the community? Well, I mean, everything in the repo is mine to maintain, in that sense. But it was created mainly by those in the community. With that said, D309, I do use, I'm in the flake right now. So I do use it every day. So if there is something wrong with it, then I'm probably going to be the first to know. You have a text-to-speech model that reads out messages like Rich Hickey. Nix for the win. Yeah. Yeah, I have like a love-hate relationship with Nix for sure. Okay, so this is looking for the descriptor there. That's fine. We just need to clean out, build core, and rebuild. Yeah, I'm on NixOS. I've been doing Nix for, I sound like a hipster when I say this, but let me just flex. I've been doing Nix for a long time. So I wrote this thing back in the day called NixOS in place, which allows you to, the idea was that you can install NixOS on top of any existing Linux system. And then when you reboot, you're in NixOS. And so this installs NixOS like beside, like you don't have to boot into a live media. You don't have to boot into like you take a running Linux distro, any running Linux distro. We had this tested on a bunch of ones. And then you just run this script and then reboot, and you'll boot into NixOS and you'll still have your old distro there, and all your files and everything there. So this was needed because back in the day, so this was, I started 11 years ago. I wanted to run NixOS on DigitalOcean, and DigitalOcean didn't have the way to boot custom images. So you weren't able to boot your own images. You could only boot their Debian or their like CentOS or whatever distros they had. And so I ended up booting up a droplet that was Debian, and then I wrote this script, set of scripts. It has multiple stages, and it's just some bullshit. But to change the Debian droplet effectively into a NixOS droplet. And I'm still running that droplet today. Of course, it's been, rebooted, and I've upgraded the specs on it since, but like that same image that started out as a Debian machine, and DigitalOcean still thinks it's a Debian machine, but it's running NixOS. And I'm still using that as my VPS for a lot of different services that I run as of today. But yeah, and now DigitalOcean allows you to boot custom images, so that this doesn't even matter, but it did matter back then. It was an important thing back then. Okay, we're done. We've built. Can we do a jank compile now? So let me do this. Ada out. 12. Okay, so this should strip to 9.6, and it does. And oh, why? Why is this meta being realized? Because CodeGen API static because of the CodeGen. Okay, so we've swapped out the meta, but we need to update the CodeGen. Let me catch up on. So just recently salvaged old HP laptop to run NixOS on. That's cool. Refreshing, see how easy desktop setup was. Nice. What was your CMake error, D3? We have a Nix build. We have a Cachix setup. You can use the Cachix that we have if you trust it, which you should, or which I tell you you can. If you trust me, then because I'm the only one who can, like me and CI can upload to it, and then you can just get a binary build from that. Oh. No. There's no need for a paste bin. That's fine. So that is because of the submodule. Are we doing something specific about submodules in here? We're not. We had Nix instructions before, and I don't remember where they went. Like we have this Nix develop thing here. Yeah. But what I can say is so first off, you should just use the Cachix and then just get a version of, like, just get a pre-built version of jank. We already have that. This doesn't say anything about the Cachix here. I wonder where that went. Oh yeah, all this Nix stuff was deleted. Mainly because I just think it's complicated to tell Nix people what to do, because the whole Nix stuff is so fucking complicated. But yeah, if you do Cachix use janklang D3, then you should just be able to do this. If you do a Nix run with this git plus, and then the HTTPS URL for the jank git repo. Let's see, was that what you were doing? Yeah. So you used I don't know if there's a difference between doing like a GitHub colon versus just doing like git plus HTTPS. Maybe that's what you want. Like maybe this will work for you better than doing Nix run GitHub colon janklang / jank, because this is what we had before. This is what other people are using in tooling that runs every day. And so I know that this works because this whole is jank fast yet dashboard is using Nix. The whole thing's built on Nix. I meant to go here. By the way, this was our work from the ray tracer. This big old jump right here to get below closure. I love that. I love to see these huge drops. We're still slower in router here. That's fine. We're slower in router. We're slower in primes, but we are as fast, which I would say this is closure is 1.03. Oh, we're faster. We're faster. We're faster in everything else though. Love that. Another huge drop here. Okay, so I was fixing up code gen because we are so close to being able to see the benefits of this, but we're not quite there. So we had a jank eval stir right here. So this is how do we do this? So we want to set the meta on this guy. But we want to set lazy meta. Yeah, now we need to think about how to actually generate this. We have the ability to do lazy meta now. But the way that we generate constants is not actually we don't actually know which parts are meta, which parts are not. Because it's just recursively done. Forgot to ask about some C++ stuff. All right. All right, Sorcerer. What do you got? Yeah, C++ 26 reflection. Static reflection. Which people don't like. None of the C++ 26 articles or buzz around the new reflection stuff makes it clear that it's static reflection in its messaging, but they should call it static reflection, because especially coming from, you know, like the JVM or whatever, when we talk about reflection, we're talking about runtime reflection. We're not talking about compile time reflection. Harley Barley, welcome to the stream. Hope you're doing great. Try the next run with Git plus HTTPS. That seems to work. Nice. How do you think the static reflection capability will affect jank development? I don't think it's going to have a big impact on jank. I think that right now we have the ability to write a conversion trait for a C++ type to teach the jank runtime how to convert between the native type and closure data. If you wanted to marshal between, like, let's say a map representation of a struct and the actual struct, then we have a mechanism for you to register a conversion trait, which will then do that for you. So that way, if you have one of those structs and then you call a function that expects a map, you can just do the call and the jank compiler will automatically do the conversion for you. And similarly, if you have a map and you need to get a struct, then jank will automatically do that conversion for you. So we have a way to do that right now, and the jank compiler automatically puts in that marshalling for you if it detects that there's a template that describes how to do that. The static reflection would allow us to basically generate those conversion traits automatically, to the point where, like, okay, so if your struct is composed of integers and standard strings, let's just say, and we know how to convert integers and standard strings, then we know how to convert your struct. And so then, we can use static reflection to create a conversion trait that gives you a map of strings and ints, and with keywords for the keys, right? So that whole process could be automated. That's nice, but I think that the marshalling workflow is not really the workflow that most people want to go through anyway, because there's a runtime performance cost of doing all that marshalling anyway. People would rather just pass around their native values as pointers instead. Outside of that, I don't have any plans yet for static reflection, but it could be there are some things that we can clean up that I just haven't thought of yet. What's the best stuff to catch up on modern C++? Yeah. I don't know, man. There's, like, it's cool that you're getting excited about C++ again. But I don't know what a good, like, resource is for modern C++ these days. Unfortunately, like, the last time I read a C++ book, I was in college. And all of the C++, and that was before C++ 11, that's before that. There were books on C++ 11. So all of the new C++ stuff, from 11 onward, because obviously not much happened before C++ 11. You had C++ 98 and C++ 03. But all of the 11, 14, 17, 20, 23, and 26 stuff, I've just picked up based on, reading the about the new features, and like the development philosophy of how C++ is written. C++ is one of those enormous languages it's kind of like something like Common Lisp, where a lot of the people who've been writing C++ for a long time have their own way of writing C++. And they have their own libraries that they use, and it kind of has that similar sort of curse that Lisp has. And that's because the language is so huge that Bjarne Stroustrup, the creator of C++, he's commonly quoted for having said that within C++ exists a smaller, cleaner language, that's just waiting to get out. But then the follow-on quote that other people put on that is like, yeah, but nobody agrees on what the smaller subset of the language is, right? I don't know if Common Lisp is huge, but it's one of the languages where, like, my comparison to Common Lisp there was along the lines of people who have been writing Common Lisp for a long time. They all end up, or a lot of them end up having their own, basically developing their own version of Lisp, right? It's the programmable programming language. And so if you end up using Common Lisp long enough, you end up developing your own language, which is Common Lisp-esque, but is different from everybody else's Common Lisp. And I think that part of it is the breadth of the features. Like, Common Lisp does have like quite a bit of features, you know, like not everybody's using the object system, for example, or like when they build their own libraries for working with things, then Common Lisp just is like the language grows because it's programmable. And so maybe it starts smaller, but ends up being bigger. But with C++, it's just an enormous language to start with. And then people build, people kind of go the opposite direction. C++ starts enormous, and then people carve out the bits they want. And then with Common Lisp, people like build up the bits that they want. And they both arrive at like a tailored language that sort of fits what they want, but it ends up being kind of different for everybody. Ron 100, LLVM feels like overkill for this project, don't you think? Tell us more, Ron 100. Why do you think the LLVM is overkill for this project? What would you use instead? Big dependency. Sure, what would you use instead? You would use QBE. Okay. A quick backend. All right. 417 stars, last commit 9 years ago. So you want to build your production language on this? Oh, this is an example C frontend for QBE. No, that's what that directory is. Yeah, this is all of QBE. Okay. Possible if the only thing that you want from LLVM is a compiler backend, and you're okay using something that's no longer maintained. Could be that's the wrong one. But then what are you going to use for Ron 100? What are you going to use for JIT compiling C++? And what are you going to use for analyzing C++ so that you can do overload resolution, implicit conversions, and such? Like, how are you going to handle the whole C++ side of jank? what I'm getting at, Ron 100, is that you clearly have no idea what this project is. And that saying LLVM is too heavy for this project or not a good fit for this project is not accurate. LLVM is literally the only choice for this project because LLVM includes Clang. The LLVM project includes Clang. Clang is the only C++ compiler that can be used as a library. Jank has unprecedented C++ interop, which requires JIT compiling C++. So we need not only a compiler as a library so that we can do static analysis of C++ interop within Jank during compilation time of Jank, but also we need a JIT compiler for C++, and Clang is the only JIT compiler for C++. And so, sure, it's possible that we could have a different backend if somehow Clang supported a different backend, but it doesn't. Clang works on LLVM. And so we need LLVM. And we need Clang. And most people don't get burned like that because most people don't come in and make big statements about what they think this project should use as dependencies. Okay, we need to get this meta. We need to get this meta. Meta. So here's where we have our string for our meta. But we don't know if this is a meta or not. And we don't have a way of setting it. I mean, if GCC can be used as a library, then in theory, but yeah, GCC can't be used as a library, Sorcerer. Like GCC is it's not designed to be used as a library. Clang, like part of what Clang and LLVM brought to the table was that they were like production grade compilers that were actually usable as a library. It'd be great if GCC is an alternative, you know? Be nice to not be tied into the LLVM ecosystem. Hey, Zelmogazi, welcome to the stream. Hope you're doing great. You are right. You're right, Sorcerer, that, I mean, any viable alternative to LLVM for all of the features that we need, you know, like a C++ compiler as a library, JIT compiler for C++, as well as a compiler backend, is not going to be a light. It's not going to be a light alternative. So we could, if we were to parameterize this gen constant to know whether or not we're generating meta, I'm not sure of a good way to do this. We're so close because we've already put in all this lazy meta stuff. But we need to make the code gen properly handle this. So we use meta in a few different places. So we use it for array maps. Basically, we can just look at this should gen meta. So for symbols, vectors, lists, sets, array maps, and hash maps. But then we also generate it for vars, which is actually the bulk of our meta. So if we do something like this, lifted constants, right. Right now with our lifted constants, we don't know if the constant is for metadata or not. It's just a lifted constant. So maybe it makes sense to also keep track of whether or not a lifted constant is metadata. So here we use meta. This meta is just an identifier that comes from right here. So here's where we lift the meta for a def. And I would say, yeah, if we just focus on defs to start with, that's going to tackle the biggest issues. So literal is going to lift the constant, give it a name, and then place it in lifted constants, which is a map of object to identifier. So what we really want when we do a with meta here on the var why are you so smart, like how you know how to code compiler and play piano. Well, do you have any hobbies, P Ninja? Surely you would have some hobby that you know, doesn't need to be an instrument, but it's something that you enjoy doing, and so that you'd have some skill in it as well. You only know how to press electricity with your hand. I mean, you play video games? You must have some games that you're pretty good at. No, I suck at all games. Oh, okay. Feels bad, man. Honestly, the trick with instruments is, honestly, the trick with learning anything is to start young. Start as young as you can, and if you haven't started yet and you want to do it, then start now, because it's only going to get harder. I started playing piano when I was a teenager, and put a lot of time into it when I was a teenager, and it helps. So we do a with meta right here, and we put in the meta. If we didn't lift the meta, what if we didn't lift the meta here? And we did a special case for def, where we just hold the meta object, and then we convert the meta to a string here, and then we can use a with lazy meta. I appreciate the follow, P Ninja. Have a good one. Thanks for stopping by. Yeah, let's sidestep this whole thing right now, and let's do one of these and one of those. Def runtime object ref meta and meta instruction def instruction def runtime object ref meta runtime object ref meta def meta. Okay. And then here, I just tried to spell escape, but I have no idea what it was like BSCA. I wasn't anywhere close. Okay. This. We can do this and this. And then we'll just change this to a with lazy meta. Yeah, we could have just done this for vars. Maybe that's the better long-term solution if that's the only thing we need it for, but you don't know sometimes. All right, so we have our string and we'll have a ref and we're gonna call that source. Var. And we're gonna return this. And then we're going to say yeah, I wonder if we need lazy meta on anything other than vars. Like other things can have meta, but it probably doesn't matter. But yeah, having everything lazy will give us the best startup time performance. So like, there's nothing wrong with that. It's just that the biggest bang for buck was going to be like if we just wanted to do bang for buck, then we could have just done vars. Yeah, meta here is. Hey, CubeDM, welcome to the stream. What is that? Is that, I swear that was what I just fixed. Yeah, I just hadn't recompiled. Rewrite. IR rewrite 107. I'm commenting that because I don't know if we want it. And if I remove, like, it's helpful for me because if I remove it in the diff, and then when I look at the diff, when I go to commit, I'll probably be like, oh, okay, yeah, I want to remove that. But if I comment it in the diff, when I go look at the diff before I commit, I'll be like, did I want that? You know, it'll prompt me. So it's a little language I have with myself. Okay, so all that compiles, and now when we start up, vars, so IR meta doesn't get lifted. before we do that, I actually want to just be safe and clear out all of that. So IR meta doesn't get lifted. We keep it here. We pass it on. We convert it to a string, escaped string. We use with lazy meta. With lazy meta, just resets the meta based on the source. So it's not actually read. And it's not going to be read until we do a get meta. Yeah, so this is only going to be doing lazy meta for vars to start with. Although everything else supports lazy meta, we're not actually giving everything else lazy meta yet. But let's take a look at what the win is actually going to be for this. But yeah, we need to wait until we compile closure core twice, and then compile the nrepl server to C++ files, and then compile the C++ files to object files, and then link that into our phase 2 jank binary. So there's still a lot of compilation that needs to happen right now before we get to our release phase 2 jank binary. These things get more and more complex. I swear. The AOT setup that we have now, in order to get the whole static runtime working, we used to have a libjank. I think, well, what did we used to have? Used to have a libjank.a, which then became a libjank standalone phase 1.a, which then became a libjank standalone.a, which is phase 2. So this is what we used to have, like 3 different static libraries, and our final one is libjank standalone.a. Now we have libjank common, libjank dynamic, libjank static, libjank compiler, and then we end up creating libjank dynamic runtime phase 1, which is libjank common, dynamic, and compiler, and then libjank static runtime phase 1, which is common and static. And so basically common has all of your the common runtime stuff that everything needs to have. And then if you want a dynamic runtime, then you need the compiler, and that's what depends on Clang and LLVM for JIT compilation and everything. And then this dynamic and static stuff, these are implementations of the same function. And so you can't link ever to both dynamic and static at the same time, because then you'll have a multiple definition of the same function. And so we only have things inside of these libraries that can't be in common because they require different implementations depending on which runtime that you're on. And so with these 4, then we can create these 2. And then for release builds, we can create these 2 by taking same thing instead of phase 1. Now it's all the same stuff, plus the compiled core libraries, closure core, closure string, nrepl, and so on. So like our whole build system ends up like being a lot more involved in order to be able to get all of these libraries. But I don't like, this is the cleanest approach I can see. And it is, I mean, it is pretty clean. It is nicely isolated, but it's just complex because we need a lot of flexibility. Yeah, see you, Johnny. Thanks for hanging around, man. I appreciate the subscription as well. Have a good one. I'll catch you next week. Yeah, I got to get my results in 3 hours if I want to keep everyone and have them see the end result. If it takes 4 hours, then it's too long. Who has 4 hours to see someone implement something? It's a long time. Especially for folks in Europe. I think it's like 2 a.m. for Johnny. So this shouldn't be any slower because all we've done is, yeah, the lazy meta shouldn't change things. This is all just lazy meta. And then updates for private meta. Doing a read string there. And then the lazy meta. That's it. Yeah. All right, we get to watch. Impatient. I'm impatient. I just wonder if there's something wrong. Wouldn't be the first time. Something triggers a infinite loop or something. Did we fuck something up with lazy meta? because this shouldn't take this long. Even for release build, I think. I just went through the diff. We could always peek in with a debugger, see where it's spending its time. So this is the right here. So currently trying to build the closure core object file. Makes sense because we don't see the object file here. I wonder if something I changed here ended up affecting having some sort of side effect. Because this backtrace basically says that we're spending our time compiling C++ code, which is expected. We are realizing a deferred C++ function, which is a lazily compiled function, just like I talked about before. So no particular issue shown from here. But this shouldn't take more than a few minutes. So every def gets its with lazy meta. And then we otherwise don't lift that constant. That's the main difference. Let's take a look now. Where are we spending our time? What do you know? Compiling C++. So yeah, this is the same trace, same place. wonder. I wonder if there's a saner way around this. Like, for example, if we stash this and just do the var, because I don't know if all the other lazy stuff is somehow causing an issue. Let's do that, because it shouldn't take this long. So I want lazy meta. And so what we're going to do here is we're going to change var to have lazy meta. This is the var. Then we have a set meta, which is going to, oh, this is going to call with meta. That's fine. And so we'll do meta set m, and then with meta, we're going to do it with lazy meta. Let's not do that yet. All right. All right, we'll try to get this working before I call it. 290. I'm gonna go use the restroom while this compiles. linker errors because we don't have lazy meta added. That's fine. Okay, now we start generating the core libs. And this is where we were before. This should only take a couple minutes. And meanwhile, I'll get this instruction, HTTP. Okay, that should be all the changes necessary. Yeah, see, we already have the object file and the CPP file, and it took a minute. And now we have all of these. So we waited, we waited like, I swear, 5 minutes, and we weren't getting the result before. So we definitely fucked something up. All right. Okay, so for this, meta is going to be an object. So we want to do a toCode string on this guy. And then we want an escape util escape. Do the same thing here. Okay, so we should be good to save all of these. All right, so this, if we were to compile, what are we doing now? Because we're returning nil here. So if we undo this, all right. So just putting back in the IR changes to forward the meta rather than lift it. And then we're only doing that for vars. If I had been more clever, I would have realized, I would have tried this from the beginning and saved myself 2 hours of refactoring. But I wanted to apply this wholesale and sort of get the benefits all around, which I still want. But the problem with that is, like, I fucked up something along the way. And then that's a lot of changes that end up going in. And we don't know, like, maybe it's this VAR related one, in which case, like, we would see the effect here. Oh, actually, we need to cancel this. We need to... So yeah, it's possible that the changes to the VAR alone end up affecting the compilation to where this doesn't finish in the same reasonable, like, minute or so. In which case we can figure that out, fix that, and then go back and pop that stash to get all the other lazy goodies. But if this works, then that means that some of the other changes in all of the big lazy refactoring ended up causing the issue. I don't know yet. It seems like it could very well be this. And the only thing that changes with the code gen is we don't lift the meta. And then we turn it into strings. Well, I realized one issue. We actually need quotes. So I wonder if that was failing because it was trying to compile a whole bunch of invalid code. I would expect that that would fail sooner. Yeah, I would expect that that would fail sooner. Okay, so this finishes now in a reasonable amount of time. So that means it is the other changes. No, it wasn't the other changes. It was this lack of, it was the lack of quotes. Yeah, I don't know what that triggered in Clang, but Clang really didn't like it. Cause now we're rolling. That's fucking crazy, man. You forget some quotes and then the compiler, like the JIT compiler just hangs. Just hangs. But it wasn't deadlocked because the invalid call to. Okay, yeah. So this is because we're not evaling the meta. So we have a lazy meta. We need to not only read it, we need to eval it. Eval takes an object. Let me stop before we do that. So what we actually want is probably jank eval stir. Which is part of the CodeGen API. Like so. And so this will give me so for jank that'll actually eval, and for the static runtime it's just going to do a read string and not eval. An API dynamic, it's going to do a read string and then also eval. All right. So now we just compile these. Maybe we'll have everything we need. So yeah, we're actually compiling the generated C++ code. So jank can generate object files, like for closurecore.o, but it can also generate C++ files. And so the whole like nREPL server gets generated to basically a C++ project, which then we compile into jank itself. So the final jank phase 2 binary has the nREPL server as well as Clojure core and the rest of the core libs baked right into it. Okay, cool. So assuming this links, we should be good. And do we see our final result? So let's, what was I want to remove these, and then I want to do my compile, and then I want to do my time, and that's it. And that is it. And so we should be able to see here that we still have meta if we want it. Yep. The meta's still there. But we don't need to evaluate all of it from the start. Welcome to the stream, Uncannity. Hope you're doing great. So, after adding lazy meta to vars, we did 24, let's say, because I saw a 22 and I saw a 25 and I saw a 24, so choose the one right in the middle, because this was 22. Nice. So yeah, we dropped from 82 to 24 milliseconds in order to by adding lazy meta for vars. So if we remove all metadata reading, then we're down to 12, which means that clearly we're still doing some because we have metadata on things that are not vars, like symbols and lists and stuff like that. And so that's where the full changes that I did are gonna apply. I think that we could probably just do those now. So let me do a get stash save. I just want to see if we can test those final changes, because that should drop us all the way. So get stash list, stash save lazy meta for vars only, and then we'll do a get stash apply of stash. So this is going to be affected as so stash at 1. Apply stash at 1. And then the big problem here was that we didn't escape this. That was the big problem. So if we do this, build core libs and then build. All right, so we'll do a final build. We'll do a final build to see if we can get this dropped even more to be closer to 12. But that's already a big win. Like I was saying it would be around 20, and I was hoping it would be under 50. So we are definitely around 20. We are definitely under 50. That's already a big win. I think if we could drop if we can have the lazy meta for, oh, you know what? I didn't actually have lazy meta added for everything else yet either. I had added lazy meta support for them, but not to CodeGen. So this building the rest of the stuff isn't gonna change that. We should end up just getting about the same time. So yeah, we don't even need to wait for that. So yeah, I need to, next step is to go in and add the CodeGen for lazy meta for the symbols and lists and vectors and array maps, and hash maps. Basically everything that's not a var that can still hold meta, if it has meta for CodeGen, we should still just do the lazy version of that. Then the other, we could take this a step further, which is when we were adding lazy meta, we made it so that whenever we had changes to persistent vector, like you conj onto a persistent vector, we make a new persistent vector that has the updated data, we were realizing the meta in order to pass it in, because the constructor for a persistent vector didn't take a lazy meta, it took an actual meta object. So we should just change those constructors to take actual lazy metas. And then we can forward our lazy meta onto other later data structures as our data structures change. And that way, if you assoc onto a persistent map, you don't need to pay the cost of realizing the meta just to create your next persistent map. So yeah, couple steps we could take this further to remove those meta costs and push them all the way to the edge of where like we actually just need to get the meta for something, we need to get the source for this thing, or the actual user code wants to grab the meta from a value, in which case we lazily force it to be parsed and evaluated. But yeah, this is the exact type of gain I wanted to get, and we did get it on a stream. So I'm pleased. I would already be pleased with 24, but we're going to be able to get more once I add the code gen for the non-vars, but all the other data structures. Because this is why I did the testing first, to see like, okay, if I remove all metadata reading, how far can we get? This is like our baseline of, these 12 milliseconds are spent doing non-meta stuff. This is the rest of spinning up the jank runtime and printing hello world. So we're not going to be able to get below this by doing lazy meta, but theoretically we could get to this point. And we'll see what the rest of the changes where we get, but I'm pleased. Whew. I'm pleased. All right, folks. I hope you had a good one. Hope you had a enjoyable stream with me. I'm really I'm pleased with the outcome, and I'll follow up next week with more AOT stuff. I don't know exactly what we're going to be working on, but we're going to be done with all this stuff. All this stuff should be in main by then, so you guys can start using it. And we'll be maybe we'll talk about the build system, the new fancy build system next time as well. But until then, have a good one. Adios.